In this video, we will demonstrate 5 simple experiments related to potential energy. Experiment number 1, rollback can. These are the materials we need: a can and rubber band, 2 nails, tape, and a small weight. First, we need to make a hole in the center of the bottom of the can. Then, we need to make another hole in the center of the lid. Now, I attach the rubber band to the battery using tape, so it looks like this. Push one end of the rubber band through the hole in the bottom of the can and secure it with a nail. The other end of the rubber band should be inserted through the hole in the lid and secured with another nail. Our can is ready for testing. When we roll it, it comes back. Why does it happen? I will create an identical item, but this time using a can that is transparent. As the can moves forward, the heavy battery does not rotate with it, causing the rubber band to become twisted and store energy in the form of potential energy. When the can is released, the potential energy stored in it is converted to kinetic energy, and the can moves again. Experiment number 2, popsicle stick explosion. For this project, we only need popsicle sticks. I have used these tongue depressors, used for intraoral exams. I am doing the tutorial on a rubber tatami because it is softer and more compressible than a hard floor. It easily allows us to add the sticks to one another by sliding underneath. Lay one popsicle stick over the other to make an X shape. Place the third stick underneath the first stick and on top of the second stick. Place the fourth stick under the first stick and on top of the third. Continue adding sticks in the same way until there is a long chain. Make sure you keep pressure on the last stick just placed. Let go. Each popsicle contains potential energy, which is converted to kinetic energy when the last stick is released, causing a chain reaction. Experiment number 3, rotating bottle. For this experiment, we need an empty bottle, 2 curved straws, a string, and water. I'm going to drill 2 holes on each side of the bottle, near the cap, and do the same near the bottom. Now I'm going to cut the bottle using a scissor near where I have drilled, and attach either end of the string. I now fasten a shorter length of string into the center of the first one. We just need to insert the straws into the holes. We are ready to test it. I am going to fill the bottle with water and hold it at the tip of the string. The bottle starts to roll. The water inside the bottle storages potential energy. When it passes through the holes, it is converted to kinetic energy, and the bottle spins. Experiment number 4, balloon ball. All we'll need is a sizer and a few balloons. We must first blow up one balloon, however, not excessively, just a tiny bit. I'm going to cut another balloon in this place after that. I'm going to wear the balloon that I inflated with the cut one, and do the same thing with others. I think I used 10 or so balloons total. Let's test now. There is potential energy contained in the ball when I hold it this high. The ball develops kinetic energy when I drop it. When it strikes the ground, the ball deforms and restores potential energy. Another conversion of some of this energy into kinetic energy causes the ball to ascend. However, because to the conversion into another type of energy, such as sound, there was a lower high. Experiment number 5, pendulum. In this experiment, an apple and a string are required. One end of the string will be fastened to the apple. I'm going to tie the other end in a tree after that. The apple has potential energy when I hold it this way, close to my face, and it transforms into kinetic energy when I let go. But the apple will never hit my face, due to the law of conservation of energy. Energy can neither be created nor destroyed. You can do an experiment that is more risky if you believe in the principles of physics. I'm going to use this object now, made of concrete. Bonus, exploding a watermelon. If we drop a watermelon from a certain height, it will crack because of the gravitational potential energy that is transformed into kinetic energy, as we have already seen. But can the elastic potential energy of rubber bands have the same effect? Let's try. The first one is already gone. 627 rubber bands, and the watermelon exploded. Unfortunately, I turned off the camera at the exact moment, but we can still see the damage. That's because it doesn't matter what name you give to the energy, gravitational or elastic. Energy is energy, and will make a mess anyway, or we can call it work.